Hello all, this is Netravati from Masai School. There are many things in technical world. But today we are here to know something about sorting. What does sorting means? Sorting is nothing but rearrangement of the things. If the things are not in the order, if they are in shuffled way, the rearranging of the things is called sorting. How can sorting happen? There are many ways. For example, there are many manual methods where sorting is done. So there are some algorithms also written for sorting. For example, let us see. First, let us know what a sorting algorithm means. Sorting algorithm is the algorithm. It is the thing which rearranges the things based on the comparison operators, based on comparison methods by comparing its neighbor element. So this kind of arrangement is done by an algorithm called sorting algorithm. So there are various kinds of algorithms which are, for example, the selection sort, quick sort, merge sort, bubble sort, and etc. 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 So among all these, today we are here to know something about the bubble sort. So first of all, what does bubble sort algorithm means? How does it work? What is the purpose of that? What is space complexity of that? What is time complexity of that? How does it work? What are the real life examples of this bubble sort algorithm? These are some things we are going to study now. So first of all, let us know what is bubble sort algorithm. The algorithm, this is the very simplest algorithm which rearranges the elements or objects or lists of elements by sorting. This is the sorting algorithm which works mainly by sorting or swapping the elements repeatedly if they are in the wrong order. Suppose here in this algorithms there will be comparison operator which compares between two elements only. It compares whether these two elements are in the order or not. If they are not in the order, then it just swaps the elements and move forward to compare the next elements. This is what the bubble sort algorithm is. So let me share the screen and will show you with the examples. See, here is the definition of bubble sort. It is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in wrong order. This is what the bubble sort algorithm is. For example, shall we study with real life examples? Yeah, definitely we will do it. As we know, when we all were in schools, we had not in colleges or in high schools, but when we all were small, there were seating arrangements. Seating arrangement was happening height wise. For example, we will just see, and there was always a teacher who used to make the seating arrangements for us. Like first bench would be there, second bench would be there, third bench would be there, fourth bench would be there. So how they used to make the arrangements? Like height wise, because everyone should see into the blackboard right here. Whichever blackboard or teacher, whoever will be standing, every students need to see that. So that is the reason teacher used to make us sit in height wise order. So before making that order, teacher used to tell us one thing. So everyone go in a queue, stand height wise. So this was one thing teacher used to tell us. But what we used to do, we had our best friend. So we had best friends. What we would do, we would go and stand together even though it is not matching our height. So we would try our luck at that time. So what was the thing? One person was there, second person was there, third person was there, and fourth person was little short. And in fifth person was there. We used to stand with our best friends. And this won't work always. This won't work always. And teacher used to come for rounds. Teacher used to come for rounds. Let us take teacher. Let us call teacher. Teacher is coming our way. Now teacher is coming the way. Teacher is checking. Okay, this person is shorter than this person. This is perfect. This person is shorter than this person. This is also perfect. This person is not shorter than this person. This person is taller. So what teacher used to do? Teacher used to swap. teacher used to swap these two persons. So how would be the order later? Again, after swapping, the order would be the first person used to stand at the first itself, and second person was standing at the second, third person and fourth person are exchanged now. Now what teacher done? Teacher said, whatever it may be, you may be best friends, but still you need to follow the rules. So what teacher made? Teacher sorted these two persons and asked them to stand in the order, and all the remaining persons are same. So this is how the bubble sort algorithm also works. And similarly, in the real life examples, we have many other examples to give, but this is one of the examples. Now, so see, the height of the students is in the ascending order. Teacher is happy now. Teacher is okay with the arrangement. Now what teacher will do? Teacher will take the student one by one. She will make to sit in the first bench, in the second bench, in the third bench, and so on. Teacher is going to do it now. This is what basically the bubble sort algorithm means. It just sees whether the adjacent elements are in the order. If they are not in the order, it just swaps. That's all. Here the swapping of students is done. Student is unhappy, but still that's okay. Teacher is happy. This is how the sorting algorithm works. Bubble sort works like this. So now let us see with the example of numbers. So for example, what shall we do? Shall we take an array? So what is our array here? Let our array is equal to 4, 3, 6, 2, and 7. This is our array. Now we shall take this array in this containers. For example, 4 is there, 3 is there, 6 is there, 2 is there, and also 7 is there. Now what will happen? We need to compare the things. One by one we need to compare. First thing, we will have 2 pointers. So first thing is, I will compare these two, 4 and 3. Are they in the correct order? No, they are not in the correct order. So generally the swapping needs to be done. So what will happen? 3 will go here and 4 will come here. This is how the swapping happens in the first step. Next, what will happen? In the next step, our array will become 3, 4, 6, 2, and 7. Now what will happen? Now, so my pointers check 3 and 4, it swapped. Now what will do? Now it will check 4 and 6. 4 and 6, are they in order? Yes, of course they are in order. 4 is less than 6. So here no swapping is needed. So what will happen? They are happy. No swapping is needed. Here also teacher is happy. No need of sorting. So what will happen? Teacher will simply move forward. Okay, 4 and 6 are fine. Later, what teacher will do? For example, what an algorithm will do? It will compare with 6 and 2. Is algorithm happy here? Because 6 is greater than 2. 6 is greater than 2. There is definitely a sorting needed over here, swapping needed over here. Now what will happen? Now the algorithm will swap this 2 and 6. It will bring 6 here and it will bring 2 here. So this will what happen in the second step. So what will be our array now? Our array will be 3, 4, 2 will come here. Then 6 will go here and 7 is there. Okay, my algorithm went up to 6 and 2. Now it should compare the next element. So what it will do? Now again it will come 6 and 7, it will check. Yes, they both are in order. This is the last element. So this element is fixed now as there is no next element to compare with this. And algorithm is happy. It did not swap anything here. So this is how the thing will happen in first pass. This is the first pass. In first pass, algorithm checked 4 and 3 were not in the order. It changed, it swapped 4 and 3. Later it went to 3 and 6. Later it went to 4 and 6. They were in order. It did not do anything. Next it went to 6 and 2. They were not in the order. So algorithm got angry. It swapped the both of the numbers. So now again 2 and 6 came in the order. Later the pointers went to 6 and 7. Yes, they both were in the order. The algorithm did not swap anything. So this is how the first pass happened. Now, next what to do? Can we think of that? Next what to do? We need to go to the second pass, because algorithm don't know whether the swapped elements are they in order or not. Algorithm needs to check it again. So we need to go to the next pass. Now let us see the next pass, how it is going to happen. So here, after first pass, this is the array we are having. Now we need to check with this array in the second pass. We have the array 3, 4, 2, 6, and 7. The algorithm is passing to 3 and 4. Yes, 3 and 4 in the order. We need not to do anything. So algorithm don't touch 3 and 4. This is completely fine. They are in order. So what algorithm will do? What the pointers will do? They will just move forward. So they will check 4 and 2. Whether they are in order? No, they are not in the order. So algorithm will just swap this 4 and 2. My 2 will be here. My 4 will be here. Let us quickly write the order. So my 3 is here. 2 has come here. 4 is here. Next 6 is here. And 7 is here. Okay. Later what will happen? My algorithm is happy now because it swapped 2 and 4. Now it will just check 4 and 6 whether they are correct or not. Yes, they are in order. Now as 7 was fixed in the last iteration itself, now this is the last element which will be compared. And as it is in the order, now 6 will be also fixed. And later again it will not be considered for comparing purpose. Now this is how the second iteration happened. And up to here, the elements are good. But still, algorithm is not confident whether all the elements are sorted or not. Because one swap took place between 4 and 2. That is the reason what will happen. It will again go to the next pass, that is third pass. This is what happened in second pass. When algorithm passed second time, this is what happened. In the next pass, what it will do? Again, it will take now 3, 2, 4, 6, 7 is our array. Now, next again it will take in the next pass what will happen. So by here we completed our second pass. So now we need to go to our next pass. Let us just quickly separate it by just drawing a line. Now when we go to our next pass, we will have our 3, 2, 4, 6, 7 as the array. 3, sorry. We have our 3, 2, 4, 6, and 7. Now, what algorithm will do? Now, algorithm will come to the first two elements. It will just check first two elements. Whether these two elements are in the order? No, definitely they are not in the order. So, algorithm will just shift these. It will swap these two elements. Now, my array is like, my array contains the number 2 at the beginning. 2 will come first, 3 will go here, 4 will go here, 6 will go here, and 7 will go here. Later on, what will happen? Again, my algorithm will move forward. It will compare between 3 and 4. Yes, they are in the order. It will not swap that. And as 4 is the last element now, 6 was fixed in the last iteration, and 4 is the last element. 4 is also fixed now. And these two are sorted. Again, there is no need of one more iteration, but still algorithm is not confident whether all the elements are in order or not. So now after getting this 2, 3, 4, 6, 7, so again algorithm will go for rounds to check whether they are in order or not. Now we have 2, 3, 4, 6 and 7. Algorithm will come. It will check the elements whether they are in order. Yes, 2 and 3 are in order. 3 and 4 are in order. 4 and 6 are in order. And 6 and 7 are also in order. The array is completed and this will be the final array. This will be the final array, sorted array that we will get as output. This will be the final sorted array that we will get as the output. This is how the bubble sort algorithm works. The biggest thing is, the biggest advantage of bubble sort algorithm is it is very easy to understand this array. As there is only swapping processes takes place, it is very easy to understand this bubble sort algorithm. So that is why people prefer this. But there is also one more big disadvantage of this, that is time complexity. Time complexity of, what is the time complexity of this? Time complexity. Time complexity. Time complexity of this goes to O of n square. As it goes to O of n square, so what will happen when it goes to O of n square? Definitely, when it is in the huge data, when huge data is there, it takes a lot of time. This is one of the biggest disadvantage of this bubble sort algorithm. But the space complexity of this is big O of n. Sorry, it's not n, it's 1. Space complexity is O of 1, as it doesn't require any of the extra space. Only the swapping things are done and no extra space is required. So this is how the thing is there. Now quickly let us go to the implementation part and check how it will be implemented. Okay, as I said, we shall look into the implementation part. So for implementation, I'll be showing you generally, not in any of the language. For example, we'll be writing a function like it is bubble sort. We'll write bubble sort and we will just consider an array. And when we go into this, we'll just take a for loop. We will run from where to where we need to run it. We need to run it from 0 up to where, from 0 to array dot length. We'll be running it from 0 to array dot length. For example, we will just take it as I will run from 0 to array dot length, and next we will just take the j loop. J will run from 0 up to array dot length minus I minus 1. This is what, as I said, you right, the last parameter, the last element will be fixed when one iteration is done. That is the reason it will be running up to here. So after this, after for loop here, it will just check if, okay, I'll just change the color now. Okay, now if condition will come. If what is the condition that is checked over here? If my array of j, the pointer in the first position is greater than array of j plus 1. If my element in the first position is greater than the element in the second position, then definitely they are not in the order. At that time, what will happen? Here the swapping takes place. How does swapping takes place? How does swapping takes place? How does swapping takes place? So, okay, now let us see how swapping takes place. Let us again change the color over here. To swap the numbers, first of all, by taking the number, I will just use my temp here. So what will happen? I will just take my temp. Temp is equal to, what I'll do, I will just store my array of j in the temp. After that, what I'll do, I will just make array of j is equal to array of j plus 1. Later what I'll do, I will just add my array of j plus 1 with my temp. So this is how the iteration takes place over here. Now what will happen? The if condition is closed. Later what will happen? My for loops are being closed. Not specific with color, but that's fine. Later on, after this, I'll just print my array. I will print my array. So, what is happening over here? So, in this basic example, what is happening over here? So, the thing is, this function is taken. My first for loop is running from 0 to array.length. For example, let us take array is equal to the same array example, that is 4, 3, 6, 2, and 7. This is the array we are taking. My for loop, I will start from 0 and it will go up to array.length, and my j will start from 0 and it will also go to array.length minus I minus 1. As my I is 0 now, j will go up to end. So my j as the first part, it will come to this 4 and 3. This is array of j and this is array of j plus 1. It will just check if my array of j is 4 is greater than 3. 4 is greater than 3. So swapping is done here. Next, it will just go to next elements. It will just check. Now 4 is here. So now what has happened? 3, 4, 6, 2, 7 is there. Now again it will go to the next element. Like now after swapping, it will just check with 4 and 6. Yes, they are in the correct order. It will not touch anything. It will just go to the next step, 6 and 2. Yes, they are in the reverse order. They are not in the order. It will just swap as 6 is greater than 2. It will swap. Now again my array will become 3, 4, 2, 6, and 7. So after this, again what will happen? Again, my algorithm will check with 6 and 7. They both are in order, so algorithm will do nothing. So it will come to the next step. Now one loop is completed. Now it should go to the next. Now I will be increased by 1. That is, my 7 is fixed over here and it will not come up to 7. So that was how the algorithm will work. Next, my array will be there. Now the algorithm, my j will come here. It will check 3 and 4. They are in the order. It will not touch it. It will check 4 and 2. Yes, they are not in the order. It will just swap. So after swapping, what will happen here? So my array will be now 3. 2 will come here. Next, 4 will go here. 6 is here and 7 is here. So 3, 4 is done. 2 and 4 is also done. Again, it will check with 4 and 6. Yes, they are in order. Okay, they're okay. Algorithm is happy. It will just fix the 6 and it will not go up to their next. So in the next step, what will happen? In the next step, again, algorithm will check with 3 and 2. They are not in the order. Again, my algorithm will swap. 2 will come first. 3 will go next. 4 is here. 6 is here. 7 is here. After checking 2 and 3, it will check 3 and 4. Yes, they are in order. 4 and 6 are in order. 6 and 7 are in order. After this, again, one more iteration will be done just to check whether they are in right order. If they are in right order, this will come as the output. This is how the bubble sort algorithm will work. As I said you, the time as we are using 2 for loops over here. This is 1 and this is 1. The time complexity of this will be O of n square, which is biggest disadvantage of this, and space complexity is O of 1. So it doesn't use any of the extra space. That is the reason. And this is how the program works. By this, we can just say that this sorting algorithm is really good algorithm, but still there are still many disadvantages when there is larger database considered. Because when there is larger database, so much of database cannot be sorted using this algorithm. That is how this will work. And this algorithm is really beautiful algorithm for smaller databases. So thank you. I complete my algorithm over here. Thank you for your listening.